Today we are going to take a look at adding and subtracting polynomials. So you'll notice I underlined this poly. The prefix poly means many. So we're talking about adding and subtracting multiple things together. So up until this point, while I didn't call it that, we've been looking at adding a monomial, right? A prefix of mono means one. So a monomial plus a monomial, one thing plus one thing. So today we're going to look at how we add many things to many other things. Now the good news is, just like this whole entire unit, the rules don't change, which is the one pro we've kind of continued to mention, which means when we are adding and subtracting with polynomials, we are going to add and subtract the coefficient, right, that big number in front, and we will keep the exponent the same. So for example, let's say we are given 6x to the third plus 5x squared minus 4x, right? This is a polynomial. It has many terms. In fact, it has 3 terms, so this is called a trinomial. And we are going to add that to 5x to the third minus 7x squared minus 2x. So something with 3 terms being added to something else with 3 terms. Now, when we're stacked like this, it kind of makes it nice and neat, because we're basically just going to treat this like multi-digit addition, and we're just going to add straight down each column, right? We already have all the like terms stacked. So 6x to the third plus 5x to the third, we should already know how to do, and that gives us 11x to the third. 5x squared plus a negative 7x squared gives us a negative 2x squared, right? Because the exponent stays the same. A negative 4x plus a negative 2x, well, 2, right? Negative 4 minus 2 gives us a negative 6 and x because the label stays the same. And then this is just our answer. Can't go any further with this because these don't have matching exponents, so there's nothing else that we can do. Our final answer is just 11x to the third minus 2x squared minus 6x. Okay, so let's look at another one, but this time with subtraction. Maybe we have 7w to the fifth plus 8w to the third minus 2w squared. Okay, and we are going to subtract 5w to the fifth minus 2w to the third plus 5w squared. Now, just like we did with systems, so last trimester, remember, we really did not like subtracting with systems. We always multiplied through by that -1. We changed it to adding the opposite. That is the exact same approach that we want to take this trimester. So whenever we see that this is subtraction, we are going to change this to addition, and we are going to take that negative all the way through, right? We're really multiplying each of these by -1 or taking the opposite sign of it. So 5 times -1 is a -5. -2 times a -1 is a +2. And a +5 with a -1 is a -5. Okay, changing this into addition is going to make things so much easier. There's so many less errors when we're dealing with addition than when we are dealing with subtraction. And then now we're going to do just like we did above. We're just going to go straight down. So a 7w to the fifth plus a -5w to the fifth gives us a 2w to the fifth. An 8 plus a 2 gives us a 10w to the third. A -2 plus a -5 gives us a -7w squared. So this would be our final answer. Now, it doesn't always have to be something with 3 terms, and it doesn't always have to be written in this stacked format, which means sometimes when we look at the problem, it will be horizontal. It may or may not be 3 terms, and they may or may not nicely line up. So let's say we have something like 8x minus 4x squared minus 3. And we are going to subtract off 5x minus 3x to the third plus 7 minus 2, and I'm going to squeeze this one in here, 2x squared. Okay, so now we have something with 3 terms and something with 4 terms, and we are going to be subtracting these. But again, right, subtraction, we really truly want to turn into addition and pull that negative all the way through. So we're changing the sign of this to addition, and we're passing that negative all the way through. So a positive 5 becomes negative, a negative 3 becomes positive, a positive 7 becomes negative, and a negative 2 becomes positive. Now, we could just start randomly adding whatever we wanted to add, but there's something else we want to consider for our final answers. Just like we simplify fractions and we don't write exponents as negatives, we also are going to write our answers in standard form. And it's really annoying because we've already used the word standard form with equations. Okay, but there's sort of a standard form for every unit, which is sort of the agreed upon basic approach to writing something. Okay, and standard form says that we want the largest exponent to be first. So this is in standard form because we have 5, 3, 2, right? It's going from the largest to the smallest. And that's the exact same approach that we want to take down here. So instead of just randomly adding things, we want to look through the entire problem and find the largest exponent. So the largest exponent that we see has an exponent of 3. So if we look and see if anything else has an exponent of 3, nothing else does, so there's nothing to combine it with, so I just have a positive 3x to the third. Okay, then I'm going to look at the next largest exponent that I see. So the next largest exponent that I see is 2. Right, I'm looking here. So do I see anything else with an exponent of 2? Yep, I sure do over here. So I have a negative 4x squared plus 2x squared, which will give me a negative 2, and the exponent stays the same. Okay, then I'll go to the next largest one. So I have an x, which I also have an x here. So 8 minus 5 will give me 3, a positive 3x. Then I'll look and see if there's anything else. Yep, I have a negative 3 and a negative 7, and that will give me a negative 10. Now, whenever there's lots of pieces, I sort of like to make sure I'm either underlining or circling or something to make sure I don't miss anything. But once you've made sure you've got everything in there, that means that our answer will already be in standard form. So from largest exponent to smallest exponent. Okay, and we are going to look at one last problem. Let's say we have 2x squared plus 7x plus 5x minus 9 minus 3x squared plus 7. Okay, this means now that we can take multiple polynomials. Doesn't have to just be 2 of them. Now we have 1, 2, 3 polynomials, and we can put those all together and add or subtract them. Now these each individually have 2 terms, so 2 terms we call a binomial. Okay, so we're adding up 3 different binomials. Now we'll also notice this one is addition, so that's fine. But this one is subtraction, so we want to change that to addition and then multiply through by that negative. Now, if this one was subtraction, it would only go to the 2 in parentheses following it. It wouldn't affect the last one. So now let's combine like terms. So the largest exponent that I see is an exponent of 2. So I have a 2x squared and a negative 3x squared, which gives me a negative 1x squared, or you could write that as a negative x squared, either way. Next largest that I see is just an x, so I have a 7x and a 5x, which will give us a 12x, positive 12x. And then I have a negative 9 and a negative 7, which will give us a negative 16. So my final answer will be negative 1x squared plus 12x minus 16.